He really has a passion about making a difference in the community, and We Care represents that. And so it's been a pleasure to work with him. He has been acknowledged by both pharmacy and other professional groups for his visionary leadership skills, and you'll be able to appreciate both his aptitude and his wonderful, pleasant attitude. So I introduce to some of you and present to others my boss, colleague, supervisor, and friend, Dr. Sneed.
Dr. Hill, thank you very much for that very kind introduction. I always say I'm so happy that you made the choice to come work alongside me, because if you had ever chosen to go into television, you would have definitely been the next Oprah Winfrey. There's no doubt about it. So thank you so much for that very kind introduction. Also, I wanted to acknowledge, I don't believe he'll be able to join us this evening, but my good friend Hiram Green, he's our community outreach individual that works with the Tunisia College of Pharmacy and USF Health. And many of you may know Hiram. And certainly if you've ever seen Hiram, you couldn't miss him. He's always going to be the tallest person in the room, but he's one of the most gentle people you're ever going to meet. And so we're very fortunate that he's working with us. And then finally, I really have to send so much acknowledgement to Deborah Austin and her vision for Reach Up. They've been such a stalwart partner for us from the very beginning and continue. And I'd like to just share with all of you that We Care, really the origin of We Care was a partnership that started with Moffitt Cancer Center. And it was a large grant that we had. And when that grant ended, we continued on and developed We Care. And the real mission and goal of We Care is to introduce clinical research opportunities to the community and underserved and underrepresented communities, so to make sure that we have participation when there's opportunity to advance science. And we have many other programs that we're going to be doing here in 2021, not just singularly focused on COVID, but more importantly, just coming out and letting people really be engaged in your health. So with that tonight, we're going to talk a little bit about COVID-19. I have a PowerPoint presentation I'd like to present to you all. And then as I get to the end of that presentation, please make sure that you put your questions either in the chat, but more importantly, if you have an opportunity, we'd love to hear your voice and just hear the inflection in your voice and be able to ask me anything that you want to about this presentation and about COVID-19. Part of my disclosure, I just wanted to make sure everybody knows I can't claim to be Dr. Fauci and never would claim to be on that level, but I have spent an enormous amount of time in the previous year, 2020, reading an enormous amount, studying an enormous amount. I have a background in microbiology and cellular process. And so I understand the COVID virus and COVID-19 extremely well. And so I want you all to feel comfortable asking questions. And if for any reason we can't answer, we'll make sure we do a little bit of research and get back to you. And so with that, I am going to share my screen. And before I share my screen, I just want to let you all know that the photograph you see next to my name is not me. That is my lovely wife. We're sharing. Obviously, I'm at home right now. We're sharing a computer, but I just wanted to make sure that the really pretty individual that you see there, I just wanted to acknowledge her. And I always have to acknowledge her if I want to make sure I stay here in the house. So let me share my screen here just for a quick moment. Okay, Dr. Hill, can you acknowledge that you all can see that okay?
We actually can, yes, looking good.
Okay, very good. Oh, there's my good friend, Mr. Green. How are you doing, sir? We just said your name. I wasn't sure if you'd make it tonight, but we're very happy that you're here.
Thank you. I had a little trouble getting on for some reason, but I'm good now.
Not a problem.
All right.
Not a problem. So let's just start with this particular very short video kind of outlining the relationship between We Care and Reach Up. So, well, why do we care? Why we care? Why this program? We want to improve health outcomes.
The collaboration between USF Health's Tunisia College of Pharmacy's We Care program and Reach Up Incorporated aims to bridge the gap between underserved communities and access to care. WeCare's mission is to increase the representation of diverse populations in clinical research. It starts with rebuilding trust between academic and clinical institutions through educating and empowering the community, and then providing research opportunities along with protection and advocacy for the participants.
They want to hear the story from folks who have been through a clinical trial.
You have to share all of that information with everybody.
So take the opportunity to have a better quality of life in our communities. Join us.
So let's go ahead and let's really talk about the coronavirus. Now, the actual name for the coronavirus, the novel coronavirus, is SARS-CoV-2. Now, this is not a brand new, this is a family of viruses. Now, and the coronavirus has actually been around for a long time. Here at the first bullet point, we show you that many people who have had the common cold may have actually had a version of a coronavirus or even the flu. It's estimated that sometimes between 5 and 10% of the flu that does exist within a particular year in the past years has really probably been a coronavirus. Back in 2002, many of you may recall the original SARS, and then about 10 years later, there was a mutation that occurred, and then we had the next version of coronavirus that actually was called MERS. And so 7 years after that, we had the new novel coronavirus, or the SARS-CoV-2, which is causing COVID-19. So COVID-19 really stands for coronavirus disease in the year 2019. Now, it's really important to understand that, unfortunately, many of us in the scientific and microbiology community are almost expecting that this coronavirus over the next 4 years may once again mutate, even more so than what you're hearing in the news right now. We can certainly address that a little bit later. Now here, I have a video that I'd like to share with you, and I have about two or three videos tonight that I'll share with you. They're very brief, that really help visualize a little bit more about what this virus is and help us really begin to appreciate that it's real. Portion that you're looking at is actually the inside portion of what is actually inside of the virus shell. And these are the red spikes that we often hear people talk so much about, and they're very recognizable from many photographs over the past few months. So here's an actual photograph of the coronavirus, the novel coronavirus, on the surface of an individual, a single cell in your body. Now the yellow dots are the virus particles. And I'll show you a little bit later exactly how we wound up having so many copies of that particular virus invading parts of our body. But yes, it is real for many people. And tonight we can talk about many of the things that we hear on social media. And people are calling it a hoax, and they say it doesn't exist. Well, yes, it does. And here's an actual photograph, an electron microscopy photograph of the virus. Here's some additional photographs of the virus that have been made from the actual NIH labs that Dr. Fauci and his group work in. And on the outer skin portion of the virus, you see what appears to be like corona flames that come off of the sun, and therefore that is how it actually got its name. Now, early on, people were actually wondering whether or not this was actually a man-made virus, whether it's viral terrorism. And what we've been able to determine, at least up to this point, is that we have actually done what I call Ancestry.com. We've taken the actual genetics of this particular virus, and we've linked it all the way back to some of its origins. And so everything that we can tell you and everything that we understand right now indicates that no, it was not man-made, it was not biomanufactured, it's not bioterrorism, and most of the mutations that occurred actually occurred out in nature. So let's talk a little bit more about this particular virus. The thing I want you to pay attention to, once again, are these the red spikes, what we call the S protein or spike protein. I want you all to think of this as kind of being like Velcro, okay? Being very sticky, being very much like Velcro. And we'll help you understand a little bit more about what makes this particular virus so dangerous. Now, for human beings, we all have receptors in our bodies that those Velcro portions attach onto. And the receptor in the body is called the ACE2 receptor. Now, the ACE2 receptor is part of our, a portion of our cardiovascular system, and it actually exists all throughout all of our bodies if you're a human being. And it's at that ACE2 receptor that the actual virus attaches onto, much in the way Velcro attaches onto cloth. Now, in this particular cartoon, I'd like to show here, and can you all see my cursor? Okay,
Yes.
so here, as you can see here, the virus actually attaches onto this receptor right here on a cell in your body. And I'll show you a video in just a moment, but the most important thing I want you to really get out of this slide is the fact that when it gets in there, this thing unfurls, and then this little coil is shown in blue here, but in the little video you just saw, it was represented in the color green. This is actually what winds up getting into your cell. It pulls protein from your cell, and it winds up manufacturing additional viral particles. So even though one cell may go in, 100 cells may come out. And so this is really this RNA strand right here that really makes the virus do many of the terrible things to the body that it does. So I really want to make sure you understand that. Also, you see many of the medications that we were looking at early on, trying to figure out, can we find a way to slow down or stop the spread of the virus inside of the body, including the famed hydroxychloroquine that you see here. There actually was a scientific purpose behind why we tried to use hydroxychloroquine, because early on, back in 2005, it showed some antiviral activity against the original SARS. Unfortunately, it has not shown any really sustained activity against the current SARS-CoV-2. Now, what makes this so particularly dangerous for many human beings and for many of us as patients is the fact that if you have any of the chronic conditions I have listed here, if you happen to be diabetic, or if you have high blood pressure, if you suffer from obesity or overweight, if you're a smoker, if you have asthma and other conditions, that makes you particularly susceptible to the conditions under which the virus can actually come in and damage your body in a very terrible way. And so here I'd like to show people very quickly exactly what that means. On the far left in green, you see what happens when a person is not infected, even if you have these conditions. But as you move to the middle here in yellow, or kind of yellowish orange, and then all the way to the far right in red, if an individual becomes infected with the coronavirus and you have these conditions, it really unlocks the potential for inflammatory proteins to really kind of rev up and come out and really begin to damage various organs in the body. It turns on a lot of things that normally should not be turned on. And this is what we call a cytokine storm. And so many of the things when people are saying, well, you know, they died from this or they died from that and it wasn't coronavirus, it was actually the fact that if you have a predisposition for any of these chronic conditions, the coronavirus, when it invades your body, begins to exploit these conditions. It turns on various factors I'll show you in just a moment that winds up causing a lot of damage, potential damage to organs in the body. And so over the past several months, again in 2020, we began to see many articles that came out. This has been the most unprecedented approach to science across the entire, not just across America, but around the entire globe. And so even though I'd like to show you just a few of these images here up close. So what you're looking at here are all of the different things that the coronavirus can do to your body. Again, when I say coronavirus, I'm really referring to the COVID-19 virus. We've all heard about people that get headaches when they become infected, or dizziness. Some people lose a sense of taste and smell. A lot of that has to do with the neurological system. The things that really began to concern me early on, again, back in about April of last year, was when people began reporting kidney injury, secondary to being infected. Some of the early symptoms were diarrhea or nausea, vomiting from the gastrointestinal tract. But what really began to concern me is on the far right here. And we began to have reports that came out of Philadelphia and then out of Boston of people that were having these really strange clotting factors beginning to occur in the body. And so now the coronavirus, we understand acutely, we understand that it has the potential to turn on and make your body clot in a very unnatural fashion. And also, it can attack the cardiac tissue in the heart, leading to myocardial injury or myocarditis, which is an inflammation of cardiac tissue. And so another thing I'd like to point out very quickly, because it came up this week or last week, down on the far right in the lower corner, dermatological. So now we can even have microclotting that can exist under the skin as another form of what this virus can do. And so when I talked about that ACE2 receptor, again, remember that the red spikes are going to attach onto the ACE2 receptor. Well, where does that ACE2 receptor reside in your body? And here you can begin to see that we have ACE2 receptors in the heart, we have ACE2 receptors in the intestinal tract, and we actually have ACE2 receptors in the lungs. So when we think about the coronavirus, it's not just a respiratory virus. Even though we tend to see images on TV of people being put on respirators and having breathing problems and a lot of coughing, it's not simply that. Anywhere you have an ACE2 receptor, you very likely and very possibly have the potential for that virus to attach onto the cell and begin to replicate and then bring on the inflammatory factors that then can damage that organ. So here's another video I really want you to pay attention to, because it begins to explain a lot more about how the virus infects the body.
In a world where millions of lives are under threat due to COVID-19, it is of vital importance to gain a better understanding of how the virus actually works in search of a cure. The surface of the virus particle is covered with approximately 100 spike proteins. They always come in groups of 3, in which the proteins are intertwined. Each individual protein consists of 2 parts: a globular head called S1 and a stalk-like structure called S2. One of the 3 heads is slightly bent, enabling it to connect to the so-called ACE2 receptor on a human cell. Once the connection between the virus and the receptor has been established, the human body activates the TMPRSS2 enzyme. This is a protein-cutting enzyme that proceeds to cut off the head of the spike protein. This causes a change in the structure of the virus. The S2 protein now grows longer, penetrating the human cell. The protein then retracts again, bringing the membranes of the virus and the cell very close to one another. At this point, the virus can enter the cell through a process of endocytosis. It engulfs the cell with its membrane. The virus has successfully invaded the cell and can now start to multiply, ready to overrun the system. However, we have strong defense mechanisms that try to prevent this from happening at all costs. Scientists recently discovered how our antibodies react. It's actually a very simple process. Our antibodies bind to the spike head, or S1, thereby preventing it from connecting with the ACE2 receptor and stopping the virus from spreading. Understanding exactly how this process takes place is key to the rapid development of a vaccine, making it an essential part of our ongoing fight against this global public health crisis.
So that gives a little bit of background about COVID-19, about the virus, the coronavirus, the SARS-CoV-2, how it affects so many different organs in your body and why it becomes so dangerous. So now let's talk about some of the vaccines really that are in the news and that we're all being faced with making a decision and a choice about. So very quickly, can be a very difficult slide to follow, but what I'd like to show here is that when you become infected with the coronavirus, very often, many people don't even know they've been infected, and it takes a little bit of time for that replication to begin to occur. But as that replication begins to occur, if you see the dotted lines in purple and green, it can take probably up to a week before your body really does begin to formulate antibodies to try and protect your body against it. And so for many people, what winds up happening is that some of these people wind up having the system overrun by the coronavirus through replication long before your body has a chance to build up an immunity. Now, this slide is a little bit old. It was published back in May, and it's almost a shame that we have to go back and say May was almost like saying it was 2 or 3 years ago. But the one thing that we are learning is the fact that the body, or that various people from one person to another, have varied immune responses, meaning some people can build a very quick immune response, and some people have a little bit more difficulty building an immune response. And there's a lot of complication and a lot of research behind that statement. And so we've heard quite a bit about the most current vaccines that have been approved here under what we call an EUA, or an emergency use authorization. Both the Moderna vaccine and the BioNTech and Pfizer vaccines have now been approved for use. If you look to the far right of both of those in green, you see the word messenger RNA, and we're going to talk a little bit more about this messenger RNA technology. It's a brand new technology in terms of application out in the public, but it is not a brand new technology in terms of research and development. Up on the very top, you see the AstraZeneca and University of Oxford vaccine. That just got approved over in England for use under their version of their EUA. And right here in Tampa, Florida, we are just on the verge of starting a new clinical trial with a company, Novavax. And again, has a very novel way that they produce the spike protein and introduce that to your body. Now, another thing that people really wonder, they say it seems like these vaccines came about so quickly. Well, in a sense they did, but we're going to talk about that. But they've been well studied. Here for Moderna, you can see it was studied in over 30,000 people worldwide. And for the Pfizer product, they had over 44,000 people worldwide in multiple countries. And here you see 11,000 people, 11,000 persons of color that were involved in the Moderna studies. And so that number really approaches probably about, I would say, about 10% of the Pfizer product as well. And so when we talk about, well, who is eligible, who is it studied on, how do we know it's going to work for various people? They had a very diverse group of people that were actually studied for this particular vaccine, for both of them, both Moderna and Pfizer. Again, I'd like to bring your attention to the fact that from a racial standpoint, we had close to 10% in both studies for African Americans, and for our Latino or Hispanic brethren, both had over 20% in terms of involvement. Now, everybody's wondering, what about the side effects? Or what is it going to do to you? What can it do to you? Well, the side effects for both vaccines were actually very common that we may find with almost any vaccine that's given. I'm going to explain that very quickly. The most important thing, without going into all of these numbers that you see here, if you look at where it says Moderna vaccine second dose and then Pfizer vaccine second dose, both vaccines require 2 doses. For the Pfizer product, it has to be given 3 weeks after the initial injection. And for Moderna, it can be up to 4 weeks after the initial injection. But in all cases, the incidence of having one of these side effects kind of goes up when you get to the second vaccination shot. Now, overwhelmingly, most people experience fatigue in both cases. Second to that, you had a lot of people that said there was a headache. And then after that, it kind of goes down from there. Now, when we talk about myalgia, that means that many people, you're going to have pain at the site of injection, and that pain is probably going to last for about a 2, maybe a 3-day period. However, for the headache, for the fatigue, nausea, and for the chill, all of those symptoms were gone within a 24-hour period and no longer than 36 hours from the time that you got the injection. So what is happening when you feel these side effects is not that you're getting sick, It's not that the vaccine has made you sick. It's not giving you coronavirus. This is actually your body manufacturing and revving up those antibodies that we need to be able to fight against the coronavirus should you come into contact with it in the future. And so we actually see many of the side effects if they do occur. And if you notice, it doesn't say it occurred in 100% of the people, although it may have occurred in 2 out of 3 people with many of the side effects that we have listed here. So there's no guarantee that you will get the side effect, but many people do, and we want people to be prepared for it. However, it's really important to also understand that in each one of the clinical trials from the very beginning, back even in the phase 1 trials that started back in April of last year, all the way up through November when they got approved, that a simple dose of Tylenol or ibuprofen has been very effective in controlling many of these side effects. Now, other people really want to know, well, what's inside of the vaccine? What is in there that can possibly hurt me? Well, the most important things here on bullet point number 4, they are preservative-free. They don't have any preservatives. All they really have are just a few things in there to make it be able to go into your skin, go into your muscle tissue a little bit easier. So they have a little bit of a lipid particle, or what we would commonly call cholesterol, which is very common to some of the things that you may actually encounter when you cook some of your food at home. You see things like potassium chloride, sodium chloride, sucrose. These are very common things that we encounter every day. So there are very few ingredients inside of what is being injected into your body alongside the messenger RNA. And here with Moderna, we find a very similar kind of thing here. It's really important to understand that unlike the Pfizer product, you have to add just a little bit of sodium chloride fluid into the vial to reconstitute it. The Moderna product is already kind of formulated, and so it just has to be thawed out and then provided. We don't have to really do anything to prepare it. Now, you saw that video earlier, and again, I took a still shot here, and the green area right here in the middle, that is analogous to what I showed you before, these blue RNA strands. And it's the green particles on the inside that really wind up causing the machinery in your body to cause damage. And so let me explain to you very quickly how this new messenger RNA technology works. So after you've been vaccinated, okay, you have a needle in the arm. What they were able to do, what the scientists were able to do, was to mimic a portion of that RNA strand that's inside of the virus. Now, again, it's not coming from the virus, but they were able to mimic and make it and manufacture it inside of the lab. And in this particular case, they took a portion, according to the genetics, they took a portion of that strand and they coded it so that when it gets injected into your skin, it's not going to reassemble into the entire virus. All that's really going to happen is that you're going to have portions of those little red spikes that are going to be made inside of your cells. Just the red spikes, not the dangerous part that's on the inside here. Please keep in mind that it's everything on the inside that becomes so dangerous to causing many problems with what you're finding. Now, when the body recognizes forming those little red spikes, what actually winds up happening, and let me show you, let me show you this video very quickly, and I'll just kind of narrate over the video. Your body builds the antibodies to those spike proteins, like we saw in the previous video. And when you have the antibodies, now it's going to attach onto the red spike should you become infected or come into contact with the coronavirus later, and thereby it will not allow that coronavirus to enter into your cells and thereby infecting you. So it's really important to understand when we talk about antibodies or vaccines against the spike protein, this is exactly what we have now kind of programmed your body to do. And that's what I'm showing here with all these different arrows, okay? So many people say, well, it was formed too quickly, Dr. Sneed. Well, not really. Let me explain that to you very quickly. We've been working, I don't want to say, when I say we, I mean we in the scientific community, but we've been working on building these for a very long time. And we actually have probably 7 or 8 years of experience. And we were waiting for the next pandemic. And I'll share more of that information with you here in just a moment. So here you see an article that was published back in 2013, okay? All the way back in 2013, it was published and it showed it shows that the messenger RNA was really being developed through an initial grant, primarily from what is known as DARPA, or a portion of the federal government. Now, this is kind of explaining, this is a person that was giving a testimony to a subcommittee up in Congress, and he was saying that President Obama's decision to invest in messenger RNA vaccine research, which is one platform being used to develop the vaccines in record time. So again, starting in 2013, back in 2014, and then 2015, additional work was being done to develop this new messenger RNA technology. Now, this is not the only vaccine technology, but it was the one that we knew that would be developed the quickest should we need it in the future. Now, it's also really important to understand, and I pulled a speech that, again, President Obama gave back in 2014, and he gave it alongside at the National Institutes of Health with Dr. Fauci standing at his side. And this is the most important portion I've highlighted here. And again, I'm not going to read the entire thing, but he says, so that if and when a new strain of flu, like the Spanish flu, crops up 5 years from now or a decade from now, we've made the investment and we're further along to be able to catch it. And so they were already talking back then that they knew that another pandemic was going to come along, and they understood that it takes anywhere from 3 to 5 to up to 10 years sometimes to develop a vaccine against anything, and they realized that another pandemic should have come along, and if it were deadly, we couldn't wait 2 or 3 or 5 years to develop a vaccine that we probably would need to develop very quickly. So this is really just a new version of how they were going to do vaccine development. So no, it has not happened extremely quickly. It hasn't happened nearly as quickly as we like to try and give it credit for. Dr. Hill, can you, okay, I just want to make sure you guys are still there, right?
Yes, sir.
Okay, because, okay, you popped up on my screen. Something went away for a moment. It kind of worried me.
Okay.
So again, very quickly, just to kind of help you all understand, this, even though it feels like this vaccine was developed, like we woke up in April and said, hey, we need to do something brand new. This technology has been in research development for a 7 or 8 year period. And the whole idea was to be able to develop things very quickly in response to whatever virus may be out there and may be prepared and ready to harm us. A lot of people really don't know, but when we had the Zika virus, the same company was able to go behind and build a Zika vaccine. So if Zika ever came back again, we will be able to rev that up and produce that very quickly. So many people are wondering, well, especially communities of color, have we had any oversight, or how do we know, how can we trust what's going on? Well, I had an opportunity to communicate with many people on a national level. This is a gentleman by the name of Leon McDougall. He's the president of the National Medical Association, that is primarily the African American Physician Association here in America. And so from the very beginning, they were directly involved with providing oversight in terms of the development of any and all of the vaccines that were in development for the past couple of years, for the past couple of months. And then this is where we are today. So people are trying to figure out, well, how do you determine, or who determined who is going to get what and why and how and when? And so again, back in about October, I think of September, October of last year, the National Academy of Sciences, the National Academy of Medicine, they came together and they built this 4-phase approach for how they recommended that the vaccines be distributed equitably across all persons and all communities across the entire country. And so even though here in Florida, we've had a little bit of a deviation from it, from what we have here, a lot of the focus still was on people that were elderly, that were living primarily in congregate living areas, or high-risk healthcare workers that were coming into contact with people on a daily basis. Now, I've been advocating, and Dr. Hill can attest to this for me, I've been advocating from day one that when we get to the end of phase 1 and into phase 2, that when we get to essential workers, that we needed to have teachers elevated as quickly as possible to be eligible to get these vaccines, should they choose. So it's really important to understand And so just to kind of round things up, and then we'd love to have a question and answer session from you all. Some of my real passion really began to unfold way back in April when I realized that people of color all across the country were the ones that were being most affected. And so a group called the COVID Tracking Program, they began doing a lot of work and pulling data. And so they were showing that at least back then, back in October, African Americans were dying at 2.3 times the rate of our Caucasian counterparts. And if you were American or Native Indian or in the Hispanic/Latino community, they were dying at a rate 1.5 times that of our white counterparts. Now, as months have gone along, and now we've had more people in the Midwest become infected, now we're kind of seeing that number go down, but now it's just down to about 2 times the rate of our Caucasian counterparts. And so it really began to really explain exactly how much people of color were being affected disproportionately according to their percentage of people in the population. Let me back up very quickly because you can see over time. I pulled this particular graph in October of 21. You can see we had 41,000 Black lives that were lost at that time. It increased up to 47. And now this is at 50, and last time I took a look, this was in excess of 52,000 people. So really, it's been somewhere between 18 to 20% of all the deaths that were occurring. And we also understood that this was happening all across the country, no matter what state we were looking at. Now, this came back from April of last year at the very onset of the worst part of the pandemic. So, for example, I trained in Louisiana. Even though African Americans made up only 33% of the entire population, they were making up 52% of the people that were infected and eventually dying from COVID-19. And you see that African Americans were being outpaced in every state, no matter where they were, according to their percentage of people in the population. And this kind of explains a little bit more. I was able to kind of predict, and if you took a look at the graph on the left, that's a heat map of showing people that have very significant cardiovascular complications. Now, anytime you have these cardiovascular complications, meaning hypertension, diabetes, other heart disease, and other things of that nature, you're going to have more expression of that ACE2 receptor. And early on, I took a heat map of the people and where the most significant cases were across America, and you could see that we were finding a lot of people that were overlapping that were infected and were being most affected in the very same areas where we found people that had cardiovascular complications. So just to kind of wrap everything up here, yes, the coronavirus is not the flu. It can affect multiple parts of your body. It can damage parts of your body, and we're really concerned about what we call long haulers effect in terms of having lingering effects for many, many, many months. And we're really concerned that some people, for example, that have their loss of taste and smell, they may not be able to regain that anytime soon. So now I'm going to invite Dr. Hill to come and talk a little bit about We Care and exactly some of the things that we really try and get out into the community, and hopefully we can really count on many of you to partner with us in the future. Dr. Hill?
Well, thank you first, Dr. Sneed, for that wonderful information. And certainly, I think all of us probably were able to walk away with some valuable nuggets. So to go back to what it is that We Care does, well, We Care is on a mission to prove to the community that we do actually care. And part of what we're doing is a lot of workshops like this, where we're definitely talking about important topics to include but not be limited to COVID. And then we also are trying to create opportunities for researchers to also gain insight on how to approach diverse populations and the important things from a cultural standpoint. So with the help of Reach Up and Mr. Green, we have been able to perform things like focus groups that allow us to appreciate some of the cultural innuendos and generational innuendos related to the whys and the the why nots in regards to research participation. And we have had events that then allow an interface between researchers and the communities so that they can appreciate and ask questions from both sides. So we like to use the 3 E's: expanding, engaging, and empowering both sides of the research equation with information as much as possible. We have been fortunate to interact with African American communities, West Indian and Hispanic communities for the most part, but we are also broadening out and looking at opportunities to engage with our Afro-Caribbean sisters and brothers, as well as the Seminole tribe. In the past year or so, we have made some very strong connections with the faith-based community, the Divine Nine, and other social and civic groups, and then entities like yours. And we're embarking on initiatives in Hillsborough County and abroad that will allow us to interact with business entities, as well as working with the mayor on educational initiatives so that we can be considered a pillar or a resource to others as it relates to these kind of topics, and also, especially more than not, research participation. So we are just so excited when we get these opportunities to talk to groups like you, so that when you hear the word "we care," you'll know that we care. So we do have some upcoming events that you all may receive emails about in the next few months that will again expound upon things related to research participation, and opportunities to participate in that regard. Dr. Sneed, you actually showed a very important picture I wanted to ask you to go back to, and this was our fearless leader getting his vaccine. And so I just wanted to let you know that we're not all just talk. University of South Florida has some very robust initiatives that are preparing faculty, staff, health trainees, students, et cetera, in regards to providing care. And Dr. Sneed has been in the trenches, still seeing patients since enduring the pandemic. But he, 2 weeks ago, 2 or 3 weeks ago, right before the holiday break, Dr. Sneed got his COVID vaccine. So if you want to ask him questions about his experience, he's here. If I'm not mistaken, he got the Pfizer vaccine at TGH. And so he can share with you a little bit more in terms of his experience. And we will be having some programming also that will share insights from others that have had the vaccine as well. I was talking to him today about making my appointment also. So we do encourage you all to now take the information you heard this evening and go back and be ambassadors for your loved ones, your family. But if they have additional questions, please reach out and talk to ask us for information. I think one of our first questions, Dr. Sneed, you always get everybody so excited when you show them those neat videos and pictures and data, and they want to get copies of your slides. And so both Dr. Austin and myself explained to them that we're recording tonight's workshop, and that we also are developing a document that includes not only the information Dr. Sneed talked about tonight, but other important information as it relates to COVID. What we've been priding ourselves on is capturing all of the questions that have been asked during these kind of workshops and compiling them so we can share them with people, because the information about the infection, how to treat it, has been so dynamic. And so every workshop we've done has a little different twist to it in regards to some of the information Dr. Sneed has shared. And so we will be actually broadening our exposure in terms of discussions related to the vaccine. So do stay tuned. And if you receive an email from us, just know that it's us wanting to share some of our latest and greatest insights as it relates to COVID and other topics. So at this point, I'd like to encourage all of you to use the chat feature to maybe ask us any questions, ask Dr. Sneed questions particularly, so that we can make sure that you leave here this evening with clarity about treatment opportunities, the vaccine, or any other residual questions that haven't been addressed so far. So looks like we do have one from Mrs. Marion Mitchell. She said she had her physical last month and carried an EpiPen due to having allergies, and her doctor told her that she should wait a couple of months because information is still coming out about allergies in the vaccine. How long should she wait, and what's known about the cases with those who have had allergic reactions?
I just started doing this like yesterday,
And,
Okay,
and
yeah,
we're
okay.
we're going to ask everyone if they would mute their mics if they're not speaking.
Yeah, okay, yeah, Dr. Hill, and first of all, thank you very much for just for being present tonight, and we hope that we've shared some very credible information with you on evidence-based information. This is a very important question that's being asked right now. The first thing I'll tell you is that with all of the clinical trials, so we're talking well over, at this point now, 200,000 people, we had not one reported anaphylactic reaction, or the very significant reaction that we've heard about that would require an EpiPen or epinephrine to be injected. That didn't come out until after we began injecting people with the vaccine. On day one over in Europe, we had 2 people. We had 2 more people that were in Alaska and 4 more people up in the Chicago area. The first thing I would share with all of you is the fact that, number one, all of these people were treated effectively. Nobody died from it. Number 2, the one thing that was really uncovered was the fact that many of these people, like yourself and you're mentioning here, actually knew that they had some type of very strong allergic reactions to certain proteins. And they were carrying the EpiPen with them already. So these are people, maybe like yourself, that if you have a bee sting or if you're stung by ants at a picnic or other things, that very often this very significant allergic reaction can occur. And that's why we have people like you that carry the EpiPen. So if you're a physician, in that case, we have also recommended that people go back and talk to their physician. The most important thing that's now being uncovered inside of the medical community across the country is that if we have people that are particularly susceptible to the things I talked about earlier, and it becomes a risk and benefit discussion, and we think you are at particular risk from COVID-19 and at high risk potentially of death, then some of their physicians are recommending that they go ahead and get the vaccine, have it done in a very credible area where if you need supportive care immediately, then you can receive that. Now, it kind of sounds like, well, why would you inject something that's going to cause this reaction? Well, it's because of what I said before. This has been determined that if you were to become infected with COVID-19, and you can have a very terrible outcome, including death, then that risk and then the benefit of the vaccine in those cases are now weighing in favor of taking a chance and getting the vaccine. And the other thing that we are hearing anecdotally now is that people that have gone and taken that risk did not have a reaction. So it doesn't mean automatically you're going to have it, but that is a discussion that you have to have with your physician, and you have to be empowered with the information to make a choice.
Thank you, Dr. Sneed. Mrs. excuse me, Devilia said she understood that there was an order from the governor on who gets vaccinated first, and was wondering if there was any idea when the teachers would receive the vaccine, or just the general community. And then her second question was she had the flu shot and wondering how long she should wait before receiving the COVID vaccine.
Those are 2 very important questions. Let me take the second question first. That's a much shorter response. And we're actually recommending anywhere from a 30 to 45 day interval between getting a flu shot and getting a COVID-19 shot. Anything shorter than that, we don't want to overwhelm the actual immune response and your ability to build antibodies. So, we do want to separate it by at least a little bit of time, but there's nothing in written print that says you have to wait a certain amount of time before you get the COVID-19 shot, but a general recommendation has been anywhere from 30 to 45 days. Now, on the first question, teachers have been moved into what we call essential worker status, and in Florida, we kind of have a phase 1 3-tiered system. Now, the governor kind of changed things around a little bit and said that elderly, if you're above 65 or older, anywhere in the general public, that you will be eligible to first get the vaccine before we move on to the 1C group or the essential worker group. Now, that's not aligned with what the FDA and the CDC recommended. They recommended elderly in congregate living areas like nursing homes or assisted living facilities, they be the elderly to get the shot first. In any event, we fully expect that we're going to be able to get through a number of these people. It's probably going to take about another 30 or 45 days, really, to get through the full number of people that want that shot. And once we get to the tail end of that group, then we kind of move into the essential worker group, and I believe teachers are at that point. What I cannot tell you is how long it's going to take to replenish the actual product into locations in order for you to be eligible to get it. And that's the only rate limiting step that we have right now, just having enough vaccine in given areas to give to all the people that want to get it. So we don't have a direct timeline. If I had to guess right now, we're probably looking at somewhere late March or into April before we get to the point where everybody is fit into that. But as I told Dr. Hill, I think either today or yesterday, I'm fully expecting that some people who are right now on the lower tier are probably going to move up a little bit quicker than we think, because some people up here are just going to elect to not get vaccinated. And so our recommendation right now is to not leave any vaccine stuck in a freezer or a refrigerator. If people get to a point where they don't want it, we need to redistribute it out to people that do want it. So stay tuned. But right now, it's going to take a little bit of time before that essential worker group can move up beyond all of the the millions of elderly that we have here in the state of Florida.
Okay, well, we would like some more questions. Those were all that we had so far. Dr. Austin, Dr. Russ, are you all noticing anything in the chat that I might be missing?
I'm not seeing anything at this time. I think you've answered them as they have been loaded.
Okay. Well, again, we know this information is so dynamic, and I already put my, sorry. Okay.
Yeah, I see a
Oh, yeah.
question here.
Yeah.
Ms. Rosario is asking, I think she's asking about my experience with the vaccine. I can tell you with as much honesty that I can muster within myself, when I got the shot, it did not hurt as much as a flu shot does, which doesn't hurt. I could barely feel it going in, to be perfectly honest. And across the country, everybody has kind of been reporting the very same thing. Now, I will tell you the following day, yes, I did have some soreness at that area. It was a little bit sore, but by day 2 afterwards, I was back working out again. A little bit of Tylenol. I didn't feel the pain. It didn't bother me. But more importantly, after the first shot, I didn't have any side effects. I didn't have any headache. I didn't have any fever. I had nothing. I didn't get any fatigue. Now, I'm getting the second shot on Friday. So maybe you should, if you can contact me next Friday after that, maybe I'll say, you know what, yeah, I was really tired, or I had this, or I had that, but I'm not really concerned about that at all. And let me be very clear with everybody here. It's very important. This is one of the most critical things to understand. With the current vaccines on the market, the Pfizer and the Moderna product, within 48 hours, 2 days after you get that shot, there's nothing left in your body, okay? So I know many people, and I've gotten a lot of questions, even from the nurses I work with. What potentially can happen to me this? And we're worried about long-term side effects. We have messenger RNA throughout our body all day, every day. Every one of you has messenger RNA communicating with parts of your body right now. And so let me explain what messenger RNA does, just so you can really, I like to create these metaphors that you can remember. If each one of you were on a computer and you typed in a Word document, you typed in the word vaccine, and you hit print, and you are sending a computer code from your computer to the printer. And then the printer is going to print out a piece of paper that says vaccine on it. That computer code that goes from the computer to the printer, that's the very same thing that messenger RNA does in your body. When we inject that messenger RNA, this code is like a genetic code telling your body and telling ribosomes, we call them ribosomes, in your cell, to print out a particular kind of protein. Okay, so so you have a printer in your office that you print paper on. For ribosomes, they actually print proteins inside of your body. And after that code tells it what to do, it goes away, just like in your office. The moment it prints everything out, there's no more transmission going back and forth from your computer to the printer. It's all gone. It's done. It's not hanging around. So the messenger RNA is actually gone and degraded from your body in probably less than 48 hours. I'm just being generous and adding on an additional 12 to 24 hours. But it has done its job, and now your body will have the capability of building an antibody army inside of your body to protect you if you were to come into contact with the virus. And so, again, I was talking with Dr. Austin and Dr. Hill earlier. One of my big concerns right now, to be perfectly honest, is that I have two big concerns. Number one, if we have a certain demographic of people in society, in our communities, that all get vaccinated, and that the rest of the other people in whatever group you want to divide people up into, it can be by race, it can be by age, or whatever it might be, that are not vaccinated, then what's going to wind up happening? The coronavirus is still not going to be gone, and all of that, what we call viral pressure, is going to transfer to all of the people that were not vaccinated. And all of the people that were vaccinated, they're going to have protection against it, but now the people that weren't vaccinated, they're going to have literally no protection, and so it's going to almost engulf the people that were not protected. And so I'm really concerned about that, number one. Number two, many of us around the country are really concerned that if we don't vaccinate enough people quickly enough, okay, and when I say quickly enough, I'm talking between now and the summertime, that there will be an opportunity to continue to have the virus mutate into something. And we cannot predict what it will mutate into. The mutations you've heard about so far are not new. I was reading about these mutations back in October, and we knew about it. There's another mutation down in South Africa that you're not even hearing anything about. The good, fortunate thing, these mutations, they're not dangerous, they're not killing people at a higher rate. We think they are replicating the virus at a much higher rate in the upper respiratory part here, thereby making it more transmissible, okay? So the viral components are not just residing in your lungs anymore. We think it's residing much more in the upper respiratory fashion, so that when you're out talking, singing, or not wearing a mask and just breathing, it's putting that out into an aerosolized fashion much more easily than what we've seen prior to now. And so we're really concerned that we need to get as many people vaccinated so we can shut down that transmission of the virus between individuals and between groups of people. Because if we don't shut that down quickly enough and it keeps on transferring to more and more people, it will learn more and more about us, and it will continue to mutate potentially into something that we won't be able to control. Mm-hmm. Current vaccines right now, they do have activity against these current mutated viruses. It's not like the vaccines are not going to work, they will. But we also have to keep in mind that there was a coronavirus back in 2002 that has now mutated into something completely and utterly different from what we're dealing with now. So we need to get as many people vaccinated as possible so we can shut down this transmission and at least slow down the mutation factor, and hopefully not have to worry about this for another 4 or 5 years.
So Dr. Singh, we did get another question. One was, since Ms. Lillian Cox said she had a doctor call her home today to tell her that if she came in contact with COVID, to call him and he would call in a prescription for her, and that she shouldn't get the vaccines because it will affect her DNA. I think you've kind of provided enough insight, but I don't know if you want to add to some of what you've already said regarding that.
Well, to be perfectly honest, I'm not sure what prescription he would be able to call in. There are no medications against it right now. Now we do, and I don't cover it this evening, we do have what we call monoclonal antibodies. This is the, you may have heard, again, when President Trump became infected, he got this Regeneron product. Again, we've been watching that for a long time. Actually, here at USF, we actually had the clinical trials for that product right here in Tampa. But it's not as simple as being able to call in a prescription for that. It's actually a process you have to go through. I do not, to be perfectly honest, there's nothing about messenger RNA that can affect any component of your DNA. Okay, even if you read stuff online, and Dr. Hill and I, we've heard it all. She was very fortunate to make a connection with us to a group of clinicians in Nigeria. And there were pharmacists and physicians, and we were talking with them, and they were telling us that they were hearing that the DNA can actually turn you into a whole other kind of animal. And they were reading this online on social media. Messenger RNA has zero capability of altering your DNA. There's nothing, it's farthest from the truth of anything that I've heard. It can, now if there was a misinterpretation of what he was saying there, I don't want to discount what he may have been trying to convey, but just based on the text of the question, it cannot interact or alter or change the DNA of anything in your body or anything else going on with you. That is a 100% certainty. I will stand by that with anyone around anytime, and we can actually have a very long scientific discussion about that.
So thank you, Dr. Sneed. Ms. Marion Mitchell's husband wanted to know, since there's an order on the distribution of the vaccine in certain time frames, is it advisable to take preventative measures such as aspirin or vitamins to help build the body's immune system until a person could get the vaccine? Do you find that or think that's going to be helpful?
Let me address the vitamin section first. Because, you know, again, if you go online, you're going to hear a lot of things about a lot of vitamin regimens, okay? There's nothing out there that is going to prevent you from becoming infected, okay? There's no amount of zinc that you're going to take. There's no amount of vitamin C, airborne vitamins, that brand, because that Velcro material on that virus is very clingy, and it's going to stick on and it's going to replicate. Now, having said that, I personally have been recommending, and this again backed up by evidence and published articles, vitamin D cannot be used as a treatment. Okay, it cannot be used as a treatment for coronavirus or for the COVID-19. However, we have recently had very good publications that would indicate that for people that are vitamin D deficient, that if you begin to build up your vitamin D levels in your body, that provides a platform upon which your immune system can exist and possibly rev up a much more robust and quicker manner than if you were vitamin D deficient. And so one recommendation that I've been giving a lot of people is to go and talk to your physician, get a vitamin D level. Okay, so it's a simple blood test. And if you are shown to be deficient, then begin taking vitamin D supplementation. Now, the overwhelming majority of Americans are vitamin D deficient. We don't spend any more time out in the sun like we did 100 years ago. However, we still want to have a little bit of caution in terms of vitamin D being what we call a fat-soluble vitamin. And so we don't want you to indiscriminately start taking large amounts of vitamin D without knowing what your levels are, because we can put you into an overload of vitamin D. But I have been recommending that people get that test, and if you have not been infected yet, to go ahead and start taking on vitamin D, because it will help the platform for the immune system to then respond, and also it will help the vaccine work better. Okay, so just having a good amount of vitamin D in your body can help the immune system respond better in a more robust manner. There has actually been a discussion, I'm going to call it, not an argument yet, around the country that back in 1918, when they had the first 1918 pandemic, that the people that did the best during that time period were people that were not vitamin D deficient. And then that was borne out in another study that came from around the world. And I've been reading all of it. And one study failed miserably when they tried to treat people with vitamin D. It did not work. It failed. But for people that had requisite high levels of vitamin D, it did pretty good. So that would be one recommendation I would make. The aspirin part, I can't tell you one way or the other. And Dr. Hill, I'm sorry, you're going to have to hear me say it one more time, my good friend. But in all of my years of being involved in microbiology, being involved in molecular and cellular process for a whole host of diseases, I personally have never seen a virus do what this thing does. Because I've never seen a virus that can attack so many different parts of the body so indiscriminately. Part of the problem is the fact that I showed you all the various organs in the body that can be affected. In my practice, I had a family of 4. All 4 people were infected. All 4 people had a different symptom. Okay? And so we can't, when you have no certainty of what's going to happen to you, when you have no certainty that your organ systems will not be permanently damaged, when all these different things are happening, it made me realize and scared me enough. I said, back in April, I don't want this one. I don't want to take a chance. I don't want to say, well, I'll get it and I'll be down for about a week and I'll come back like you do with the flu. I don't want any part of it. That's why. And then the last thing I'll say to you, in my opinion, okay, this is a professional opinion, there's nothing that any vaccine, whether it be Moderna, Pfizer, AstraZeneca, Novavax, there's going to be another one from Johnson & Johnson that will probably come out in late January or early February. There's nothing about any vaccine that's going to potentially damage you more than the actual virus will. That green portion that we showed inside, or that little blue strand I showed you, it has extremely dangerous potential for you as a patient. There's nothing like that in any of the vaccines. Okay? There's no preservatives in the vaccines that we can determine right now that's going to have any long-term damage or long-term lingering effect. But we do know that if you become infected with the virus, potentially there could be a problem. Now, some people have had it, they had no problem whatsoever. And that's another hour-long discussion I won't get into tonight about why I think that happens.
Awesome. Well, Ms. Rosario also asked about the mutations and whether the current vaccine would be effective or not. And I think you kind of addressed that early on.
Yeah, we have no expectation. It's being tested right now, and all the early indicators, I haven't been able to get inside information. All the early indicators are that the current vaccines are going to work fine.
Yeah. So Ms. Bellamy wanted to thank you for explaining the transmission. She thought that was very, very clear and appreciated that. Ms. Christelle Toombs inquired about whether or not there'll be a vaccine for middle schoolers.
Yeah, so let me catch you all up on that very quickly, since we're talking to GRECO Middle School, which I pass by periodically. Now I get to wave. When I drive by there now, I'm going to wave. I'm going to say, hey, I'm going to say GRECO. All right. The current Pfizer vaccine has actually been approved under the emergency use authorization for people down to the age of 17 and 16. The Moderna product is only for people 18 and above. Now, there was a lot of controversy about that. But what both companies are doing now, they have gone back, they have now initiated, clinical trials in people going back in 3-year increments from 18. So now they have clinical trials going on in people that are 15. And if I'm understanding correctly, they have just started enrolling people down to the age of 12. And what they wind up doing, they do what we call a bridge clinical trial. And they take the information that they're going to gather from people in these 2 age groups, the 15 or down to 15 and then down to 12. And once they find out that the proper dose and the safety and the efficacy and the safety being the most important thing has been established, then they take that and add that into the current clinical trial information and submit that to the FDA. So it won't take a full year. And we do believe there may be an opportunity for people down to the age of 12 to be vaccinated before the new school year later on this year in late August or early September. There's no promise on that because, you know, we have to make sure it's safe and effective, and it has to be evaluated by the FDA. Now, they're trying to go down to age 9, but I don't believe they're going to get there because I don't think enough parents will be comfortable enough to let their 9-year-old get vaccinated in a clinical trial to get enough information before the school year starts next year. But middle schoolers, I definitely think are going to be they're going to be in play to be vaccinated before the school year will begin next year. We'll have to see how that unfolds.
Okay, great. And then Mrs. Lillian Cox inquired about a phone number to make an appointment for vaccinations, and Dr. Austin provided a phone number for Hillsborough County. I just wanted to comment, I got a text this afternoon that appointments are full for this week.
Exactly.
You could get
Yes.
an appointment
Yes.
next week. But don't get discouraged, just keep calling and trying, because it goes back to what Dr. Sneed said about us making sure that everybody gets vaccinated, and that even though you're seeing, you know, pictures on TV suggesting one demographic predominantly getting all the testing and that kind of stuff, we want to make sure you all are persistent. But we also understanding that the companies are kind of short on supplies as well. So continue to pay attention to the news in terms of the availability of the vaccine.
Absolutely. I was going to say the same, Dr. Hill. I've been working with some people to, you know, and I actually talked with someone on that line today.
Mm-hmm.
And they did verify that all the appointments are filled now. They don't have a waiting list.
Mm-hmm.
And so you just have to, as Dr. Hill said, just be persistent.
Yes.
I mean, it took me, I have it on my phone now. It took me 10 times.
Mm-hmm.
To get through.
Well, my mom has been
so,
calling also for about a week and hasn't been able to get through either. And she's age appropriate. And so I tried to cheat and asked Dr. Sneed, you know, how I could get ahead of the line, but I didn't have any luck yet.
And not yet, Dr. Hill. I'm sorry.
So
there's a very important question here about cutting
yes.
the dose in half. You know,
yes.
people have talked about that.
Yes.
We do not recommend that. You should expect to get the full FDA approved dose of everything.
Mm-hmm.
Okay, if you get the Pfizer product, you should get the full dose. And then you should have a dose waiting for you when you go back 3 weeks later. Mm-hmm. And the very same thing with Moderna. Don't fall for any half dosing or we'll give you a dose now and you can come back 3 months from now. We have no guarantee of any of that working, and the initial dose is only going to give you no more than 50% protection. Mm-hmm. Okay, and that's a number that I'm really not even comfortable with telling you. So please, let's not do that.
And Dr. Sneed, could you expound upon, and only because, as you said, we've been doing these for a while now, we really want to emphasize to the group also that they won't have immediate protection. It may take a little while. So if you could maybe talk a little bit about that.
Yeah, thank you, Dr. Hill, very much. It's very important to understand, you need 2 doses. Mm-hmm. The first dose is really going to allow your body to peak at the vaccine material. Now, we have evidence to indicate that you do begin building a little bit of the antibodies after that time, but not enough. But when you get the second dose, that's when your body says, hey, you know what? I have seen you before. And now we're going to rev up and give you the full 100% amount of the antibodies that your body needs to protect you. Now, you hear that the Pfizer product was 95% effective and Moderna was 94.5% effective. It's really important to understand that even the 5% of the people in both trials that did not, that actually got the vaccine but still became infected, they had far less complications. They had no serious complication, and furthermore, they had no organ involvement. Mm-hmm. And I think that's really important to understand because getting the vaccine, you're still going to be insulted, what we call, you're going to receive viral insult from people, okay? But you yourself, you are now protected, and you will, it's very, very highly unlikely that you are going to become ill from coming into contact with the virus. So yeah, but the full antibody protection comes after the second dose, and that comes about 7 days after the second dose. So you have to keep that in mind. Even after you get the vaccine, we still need you to wear a mask. Okay, we still need you to do that because we don't want you to get infected in the interim, and we don't want you to potentially be able to infect anybody else if you come into contact with it.
So now, Dr. Sneed, are you implying that 7 days after the second injection, they should be fully protected, or will it take a little longer? Okay.
Yeah. All of the evidence is indicating that about 7 days after the second injection is about when people actually really get that the full antibody protection that should be afforded from getting both doses.
Okay, because Mrs. Rosaria asked that question, at what point are we fully protected? And I think you really made a very important point that the CDC guidelines should still be followed.
Yes.
And we are not going to be exempt from that, just because we get vaccinated, but we will have some extra protection once we do get vaccinated. But right now, because the virus is mutating and everyone certainly hasn't been infected, and we still have some people that are asymptomatic out there. So we really want to make sure you're wearing your mask, washing your hands, staying socially distant, disinfecting, common areas, and really stay inside as much as you can. Minimize the large groups, all of those things, So definitely all those rules still apply. Just wanted to
can I add on to that very quickly? Ms. Rosario, Dr. Rush, you have a great person here in Ms. Rosario. We love her. I'm sure you do too. It's also very important to understand that what we don't know 100% right now, that even if you get full protection 100%, you're not going to get infected. That if the virus gets into your nostril, we're still not 100% sure that you cannot then transmit it to other people. Now, I think we're answering that question now, but I can't tell you with 100% certainty that even though you won't get sick and you don't have the capability of infecting somebody else. Now, we're gaining confidence that getting vaccinated will shut down your ability to transmit. But we're not 100% there just yet. That evidence is still coming in through clinical research.
Okay. Very good. Well, they have been asking some very, very important questions, applicable questions. Anyone else have any other questions you'd like to ask? Yeah. Well, I did want to comment. Go ahead, Ms. Rosario. She typed yes, but I did want to draw everyone's attention to Dr. Russ's survey to make sure you complete it. And we also are going to ask in advance, in that she's sharing hers tonight. You may receive a request to complete a survey from We Care and Reach Up after the program is over also. Oh, so Ms. Rosario asked, do you think that the COVID vaccine will become a yearly vaccine like the flu, or at least seasonal like the flu?
At this current time, we have an expectation that that's probably going to be the case, at least for a couple of years. I will share with you, again, going back to the technology we talked about with the messenger RNA technology. The great thing that happened beginning back in 2013 with the ability to tailor make a vaccine for the type of virus that we're trying to fight against, even if it mutates. So if it mutates in the future, just like we do with the flu vaccine, every year when you get a flu vaccine, we're trying to build a vaccine against the most likely strain you're going to come into contact with. I fully anticipate that we may get to a point where, it'll be an annual thing. However, if we get enough people vaccinated around the world, and that's why it's so important that we have other countries getting vaccinated at the very same time, we think we can shut down transmission of the current coronavirus, and maybe in about a 2-year period, we may wake up and say, you know, there's not enough virus out there to have to build a vaccine. But right now, we do kind of think it may be annual for at least a couple of years.
Okay. Very good, very good. Well, Dr. Russ and the rest of the group, I put my email in the chat earlier in the discussion, I think when the question came up about getting a copy of the slides. And I'm going to ask Dr. Austin if she would put hers in the chat as well. And we'd like to invite the group to reach out to us if you have any questions regarding tonight's programming and or would like information about future programming or just a follow-up. You might hear from us again for multiple reasons, but we just want you to walk away knowing that We Care actually does care, and that this is not a one and done where we're just trying to come in because COVID is the hottest topic. We are priding ourselves in truly making connections with the community and becoming a common friend and resource for knowledge and other information for you. So we really want to just thank all of you for your attention and your time. We know you, many of you have had a long work day and probably want to get back to your family. We want to thank Dr. Sneed also for being definitely a beacon and a leader in this fight towards during this pandemic. It has just been such an honor to work alongside him and support his efforts. But we thank you, Dr. Russ, for your insight, for organizing and coordinating, and Dr. Austin, you continue to be such a jewel and valuable asset to these efforts. Again, I think we brought up when Mr. Green joined us earlier, I'm not sure if he's still on, but we also often times want to talk about him because he definitely helps make us successful also. So we would like to just challenge all of you to remain safe, remain conscious, and take care of yourselves. And certainly if there's anything else that we can do to help you during the pandemic or otherwise, do not hesitate to call us. So we'll turn it back over to you, Dr. Russ.
Thank you. And I'd like to echo all of those wonderful comments in terms of you know, what we do to work together as a community school. Please feel free to contact me so that we can partner with you in these efforts to, you know, just raise awareness or collect information that will help us be better in any endeavor that you have. So please feel free to contact me so that we can organize and move further with these types of events and activities. Okay. And we will also, in turn, also contact you when we're having things, just in case you want to be on the platform of anything that we're doing, or, you know, just have some insight and, you know, have people get used to, you know, seeing you as we continue to partner together.
Okay, great, 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 great.
So I'd like to thank once again everyone for coming out tonight. Again, this was very valuable information, and we certainly value your time and the expertise that was brought forward, and also the questions that were asked, because some of the questions were the questions that I think people had and, you know, maybe didn't get a chance to ask, and they were asked, or, you know, you hadn't thought of it, but it was brought forward. So I certainly thank you all, especially Ms. Rosario, you know, for those questions as they popped into your brain, to definitely share those out. So please continue, and I will also add my email in the chat if you would like to contact me if you have any questions for anything.
Hello?
Hello.
I'm here.
Okay.
Hello, thank you for joining us. We are wrapping.
Video.
Okay, we are in the process of wrapping up, and it was mentioned earlier that there are some resources that We Care and Reach Up will share for those who may have missed the opportunity. So as we wrap up, they will package that information so that it can be properly distributed. And if you, in order to be on the call, you did have to register. So they do have your contact information. So just continue to check your email to hear further correspondence. And so at this time, we're going to end. Once again, thank you all for coming on, and continue to reach out literally if you have any questions or concerns, comments, and just you can call me also at the school as well. Those of you who are parents, you have the school number, and Dr. Austin has my direct contact information. If you all have any, Dr. Sneed and Dr. Hill, if you have any other questions for me.
Okay.
So thank you again.
Thank you.
And good night.
Good night.
Night.
Was Mr. Morgan, he wasn't on tonight, right?